Hello everyone, welcome to Jazz Robotics. This is a video series for Jazz Robotics Sensor Kit. In this series, I am going to be covering 15 basic lessons. Very soon, I'll release video series for 50 plus Arduino projects that you can do yourself at home using Jazz Robotics Sensor Creativity Board. So please like, subscribe to the channel so you don't miss. To get most out of this series, I would recommend it to follow and the links are in the description section of this video. Today we are going to be covering the first part of 15-part sensor kit series. The topic is using the DHT11 temperature and humidity sensor. In this lesson, we'll go step by step and cover the following points. First, we'll start with a quick introduction to the project. Then we'll see the components required. After that, we'll understand the circuit diagram and wiring. Next, we'll walk through the Arduino code. We'll also run a simulation demo before moving to manual connections on a breadboard. Later, we'll implement the same project on Sensor Creativity board where all the connections are already provided. Finally, we'll test the complete working and conclude the project. Coming to the introduction, in this lesson, students will learn how to use DHT11 temperature and humidity sensor to measure environmental conditions. This project will demonstrate how to interface sensor with a microcontroller, that is Arduino Uno, allowing students to understand the principles of temperature and humidity measurement in electronics. DHT11 stands for, that is DHT stands for digital humidity and temperature. The number at the end, 11, identifies the specific model. This is a low-cost digital temperature and humidity sensor that provides accurate readings of both temperature in Celsius and relative humidity in percentage. It communicates with microcontrollers using a single-wire digital interface. Understanding how to use DHT11 sensor will enhance students' skills in data acquisition and environmental monitoring. Now let's look at the components required to perform this experiment.
As you can see, we need microcontroller, DHT11 temperature and humidity sensor, breadboard, few jumper wires, USB cable. DHT11 temperature and humidity sensor has 3 pins. Pin 1 connects to 5 volts or 3.3 volts from Arduino. This powers the sensor. Second pin is the digital output pin. It sends temperature and humidity data to the Arduino. Third pin is ground, which connects the ground of the Arduino.
Now let's look at how to connect our DHT11 sensor to Arduino Uno. This DHT11 is a digital sensor, so it has three main connections: power, ground and data. Connect the ground pin of this sensor to ground pin of Arduino Uno. Connect VCC to 5 volts pin of Arduino. Then connect the data pin of DHT11 sensor to digital pin 8 of Arduino Uno. Connecting this is very simple. The sensor sends temperature and humidity as a digital signal, which the Arduino reads every 2 seconds and displays on serial monitor. This makes it perfect for environmental sensing projects. Now the next part is code walkthrough. In this we'll DHT11 temperature and humidity sensor code. Next, we include the libraries required to communicate with DTH11 sensor. These libraries allow us to easily read temperature and humidity values. Second is pin and sensor definition. DHT pin 8. We connect the sensor's data pin to Arduino digital pin 8. DHT type DHT11. That is, we define the type of sensor at DHT11. Here serial dot begin start serial communication so that we can view the readings on serial monitor. This line prints a confirmation message. Then we'll initialize the DHT11 sensor. After this confirms that initialization is complete. Now moving on to the loop function. In the loop function, this line indicates that new reading cycle is started. Then delay is given, that is waiting for 2 seconds between readings because DHT11 updates slowly. Then float temperature. Reads temperature in Celsius. The raw temperature reading. Then prints the humidity reading. Here prints the raw humidity reading. Then checks if the sensor reading fails, prints the message that failed to read from DHT11 sensor. After this,
prints the formatted temperature and humidity on the serial monitor for easy viewing. Then add a separator line for clarity between readings. While we run this code, the Arduino continuously reads temperature and humidity every 2 seconds. All readings are displayed on serial monitor in real time. If there is any problem with sensor, an error message is shown. This is but effective way to monitor environmental data and use it in projects like weather stations and alarms. Now let's see a simulation demo of this temperature and humidity sensor using Arduino. First we will see about the connections. As we have seen in the wiring diagram, we'll connect the ground of Arduino to the ground of sensor, VCC to the 5 volts, then data pin of the sensor goes to digital pin 8 of the Arduino. This is the code which we have already discussed. It includes DHT and Adafruit sensor libraries. Now we'll start the simulation. Here as you can see, the serial monitor updating every 2 seconds. Here we can modify the temperature. And we can see the same readings on the console window as well. This simulation helps us understand how DHT11 communicates with Arduino. It allows us to test the code and see real-time sensor data without needing the physical hardware. Simulating the DHT11 sensor is a great way to learn and validate the project before performing manual connections. Then the next part is moving on to the manual connections. Now we'll perform the DHT11 temperature and humidity sensor experiment using manual connections on real Arduino Uno. As we have seen in the circuit diagram, wiring is done as per the circuit diagram. First connect the ground pin of DHT11 sensor to ground of Arduino. Then VCC to 5 volts of Arduino. Then connect the data pin of DHT11 sensor to digital pin 8 on Arduino. After this, the next part is uploading the code. As you can see, after uploading the code, Arduino Uno and the DHT11 sensor turned on. We can see the connections on serial monitor to view the readings. Let's look at the output on serial monitor. As you can see, Arduino has successfully started serial monitor at 9600 watt and DTH sensor has been initialized. System is now reading data every 2 seconds. Here we can see temperature and humidity values being displayed. For example, temperature is around 31 degrees Celsius and humidity is 36.80%. Now the message reading sensor data appears first, then short delay of 2 seconds followed by actual temperature and humidity readings. This shows that sensor is working properly and continuously sensing real-time data. These values may fluctuate slightly as the environment changes. Here as you can see, temperature is 30 here, now it is 31, which is expected behavior. This real-time monitoring can be used for applications such as weather stations, room climate monitoring. Now we'll perform the same experiment using the sensor creativity board, which has pre-integrated connections for easy use. This allows us to focus on the code and output without worrying about manual connections. Here we only need sensor creativity board and the DHT11 sensor module and a USB cable for power. Insert the DHT11 sensor into the designated slot on the board. Here as you can see, VCC data ground. So here we are inserting VCC data and ground. Next open the Arduino IDE and upload the same code as we discussed earlier. Make sure correct board and COM port are selected. As you can see, after uploading, LED started glowing. Then open the serial monitor to view the readings. We can see the temperature and humidity values updating every 2 seconds. Now let's look at the output on serial monitor. As you can see, Serial communication started at 9600 baud and the DTH sensor initialized. This system is reading sensor data every 2 seconds and it is reading temperature, humidity. As we have seen in the manual connections, notice that after each cycle reading sensor data, there is a wait of 2 seconds. Here I have removed the sensor for few seconds, so it is showing the message like failed to read DHT sensor. After that it continued to read the temperature and humidity. Here temperature changes from 29 to 30. As we can see, same readings can be observed when we perform the experiment on the sensor creativity board as well. Since it uses the same DHT11 sensor, the value shown in the console remain consistent across both manual and sensor creativity board demo. Coming to the conclusion, from this lesson, students have learned how to use DHT11 temperature and humidity sensor in a circuit. They gained experience reading and displaying temperature and humidity data using a microcontroller. Students understood the principle of environmental sensing technology. This foundational knowledge prepares students for more complex projects like climate monitoring systems, weather stations, or integrated sensors with displays and alarms. Thank you for watching.